Okay, today I'm going to go over the exponent rules with you. The first one is a to the 0 equals 1, which is right up here. It says that any number to the 0 power is simply the number 1. So, for example, if I give you 3 to the 0 power, you know that's equal to 1. If I give you x to the 0 power, you know that's 1. If I give you anything at all to the 0 power, it's 1, with the exception being 0 to the 0 power, which is undefined. So anything else besides 0 to 0 power is simply just the number 1. Okay, so we got that one done. The next one is just as simple. It says any number to the first power is that number. So 3 to the first power is going to be 3, x to the first power is x, and so on. Any number to the first power is defined as the number 1. These are both by definition, so there's no way to prove it. Just that's what it is. The next definition is this one. It says a to the 1/2 power is by definition the square root of a. And there's a couple of hidden numbers here. Whenever you see a square root symbol out front here, there's a hidden 2. I'm going to put that in red for us. There's a hidden 2. We never write it, but it's always sitting right there. And as you just remembered, a to the nothing is the same thing as a. That's this rule right here. For there's a 1 right here, even though we don't write it. We simply just write this as the square root of a. But the 1 and 2 are right here, and it's important because we're going to look at general cases. So the 1 is inside, and the 2 is outside, even in this case. Okay, the more general rule is a to the m over n is going to be, this is called a radical. The a goes in the middle, whatever this base is. The numerator of your fractional exponent stays inside, and the denominator is what goes outside. So it's n roots of a to the m. Okay, and that's what this rule is. So really these are the same rule. This is a particular case with 1/2. It's defined as the square root of a. This is the more general case. Okay, so these two are now done. Here's an example of it in work. Let's say I have 3 to the 4/3 power. This is going to be the third root of 3 to the 4th. And 3 to the 4th is going to be 81. Because that's 3 squared, or 9 squared, which is 81. So we got the third root of 81. So any other times you need to know this, just use this rule. But make sure you can do this, because I'll need to be able to see that you can take a fractional exponent and change it into a square root and vice versa. Okay, the next set of rules you should know already. So we got a to the m, a to the n, and the rule is you simply add the exponents. So like if I have 2 to the 3rd times 2 to the 6th, this is going to be 2 to the 9th. We just add 3 plus 6. And the reason this works is because this is saying that I have 3 2's, and this is saying that I have another 6 2's. And when I multiply these together, in total I have 9 2's, because I'm simply adding up how many 2's there are. So we can add the exponents in this case. So if you ever wanted to know why that's the case, you can do that. And same rule applies if I have x's here. We just add the exponents up, and we get x to the 3rd. All right, so we got the first 5 done. Let's look at, I'm going to get a new page. I'm going to keep going. So we already had these done. Now let's look at the division rule. So if I have some number divided by same base, the rule simply says we subtract the bases. So if I have, say, 4 to the 5th over 4 to the 2nd, it's going to be 4 to the 5 minus 2, which is going to be 4 to the 3rd power. We just subtract the exponents, and that ends up being in the denominator, or the exponent. Just subtract them, it's the exponent. So it's always top minus bottom. Now, sometimes this ends up being negative. That's not a big problem. So let's say we have reverse case, 4 squared, or 4 to the 2nd power over 4 to the 5th power. We're going to go 4 to the 2 minus 5, which is going to be 4 to the negative 3. And we'll deal with the negative exponent here in a minute when we get to this rule. But notice that it doesn't matter. It's always going to be top minus bottom, and whatever you get, you're going to get. So top minus bottom, and that's it. And the reason this works is because this is saying that I have 5 4's. So I got 1, 2, 3, 4, 5. And the bottom I got 2 4's. And I can cross out them in pairs, and I'm left with 3 4's. So if you ever want to know why that rule works, that's why. You just cross them out and whatever's left over. So that's why we're looking for a difference, which is why it's subtraction. Okay, so we got that rule done. Next rule is called power to a power. It says any number, and I raise that to a second power, we simply multiply the exponents. So 3 to the 4th to the 5th is going to be 3 to the 20th. We just multiply 4 times 5. The reason this rule works is this is something like this. I have, let's make smaller numbers so we can see. I'm going to change the color too. Say 3, 2 to the 3rd power. This is saying that I have 3 sets of 3 squared. So I have 3 to the squared times 3 squared times 3 squared. Okay, so here's my 3 sets. But each one of these squares has 2 3's in it. And when I add them all up, there are 6 of them. That's why we're going to multiply them, because we have a set of sets. And anytime you have a set of sets, you're going to look for multiplying. So 3 to the 6th power is the answer here. This is power to a power. And then let's look at another new thing. So we got all these taken care of, these taken care of, this, and I'm looking at this one. So what this says is that if I have 2 numbers and I have an exponent, now notice this is a multiply. This only works for multiply and divide, which we'll show you the divide case in a minute. Does not work for add or subtract. So if it's add or subtract, do not use this rule. We have other rules for that. But this is going to be a to the n, b to the n. And it's kind of like the distributive property in that we're going to distribute that exponent to everything inside. It doesn't matter what it is, you distribute to it. So let's say I have 2xy to the 3rd power. That means this 3 is going to go to all 3 things inside. So I get 2 to the 3rd power, x to the 3rd power, y to the 3rd power. And the rule is the same if it's division. So I have a fractional exponent, or a fraction. It just says it gets divided to both the top and the bottom. So this is 1 squared over 2 squared. And of course that's 1 over 4, because 1 squared is 1 and 2 squared is 4. Okay, and you can use these in conjunction with each other. So let's say I have 2x over y to the 3rd power. The 3 is going to go to all 3 of these. So it would be 2 to the 3rd power, x to the 3rd power over y to the 3rd power. Now notice, it works with multiply, it works with division, does not work with addition and subtraction, so please don't confuse it. Okay, and the last rule is our fractional exponents. And this says, or excuse me, not fractional exponents, negative exponents. This says by definition that if I have a negative exponent, it just means 1 over that. Okay, negative sign goes away, and I put whatever I have in the bottom or denominator of a fraction. So if I have, like, say, 2 to the negative 3 power, I have 1 over 2 to the 3rd power. And the opposite is also true. If I have, and this should have a negative in here. Actually, I'll put it right there. And what that means is that if I have 1 over a to the negative n, that's the same as just a to the n. So the negative sign ends up going away as we move it to the numerator. So if I have 1 over 2 to the negative 3, that's the same as 2 to the 3rd. Because it's 2 to the 3rd over 1 when I move it to the numerator, and I don't need this divide by 1. So the reason that was important is when you did the division a minute ago, when we looked at this case, we ended up with 4 to the negative 3. But here's what can happen, is that's going to end up in the bottom as 4 to the 3rd. So notice that when we have positive over negative, or positive over big number over a small number, and it's positive, it stays in the numerator. But if you have a small number over a big number and we get that negative, it's just going to put it in the denominator. That's all that's going on here. All right, got one more thing to show you, and that is what to deal when I have a square root in the denominator. So let me get a new sheet up here so we can do that. And let's say that I am reducing a whole bunch of fractions. Now, you know, before I do that, let me show you a big case. So let's say I have x squared y to the 3rd over x to the 4th to the 1/2 power. So this means I can do it in any order. Oh, let's put some numbers in here. So first thing I generally like to do is reduce anything inside just because it makes it simpler. First off, if I see a 2 over 4, I'm going to reduce that to 1/2. And I see x squared to x to the 4th, so that would be x to the 2 minus 4, which is x to the negative 2. And since it's negative, it's going to go in the denominator as x to the positive 2. And then I got y to the 3rd. There's no match with it, so it's going to stay y to the 3rd. Since I have something in the numerator, I no longer need this 1. And this is still to the 1/2 power. So now I'm going to take the 1/2 and it goes to everything. So in the top, I got y to the 3/2 power. Over in the bottom, I have 2 to the 1/2 power. And then x to the 1/2 power. But 2 times 1/2 is going to be 1. Because 2 over 1, or it's going to be 2 over 2, which is 1. So this is simply x here. Okay, and lastly, I don't want to have fractional exponents over here, so we're going to multiply the bottom by 2 to the 1/2 power, and if I do it on 1, I have to do it to the top. And the reason is I want to add these up, and 1/2 plus 1/2 is 1, because this is the rule where we're going to add exponents, because this is a multiply problem. So in the bottom, I now have 2 times the x, because 1/2 plus 1/2 is 1. And in the top, I have 2 to the 1/2 power, which is the square root of 2. And then y to the 3/2 power. This is already 2, but we'll put the y to the 3rd inside here. And that's our best answer. So let me just show you one more time what happened here in the top by doing it down here. I have y to the 3/2 power and 2 to the 1/2 power. And what we ended up doing is we're going to take these halves, and you get y, the square root of y to the 3rd times the square root of 2. But when I multiply things, I can put these two things together, which is why I have it as the square root of 2y to the 3rd, which is what's up here. All right, so this is our best answer. If you have any questions, make sure you ask. But this is what I was showing you about getting rid of fractions in the bottom. So let me show you one more time in case you have something. And let's go with x to the 3/4 power. And I don't want to have x to the 3/4 power. I need to have no fractional powers. So I want to make this a whole. So I'm going to multiply this by x to the 1/4 power. Because I know that 3/4 plus 1/4 is 1, and that would get rid of it. I can't do it in just the top or bottom. I just also do it to the top, because x to the 1/4 divided by x to the 1/4 is 1. So I can do the same thing top and bottom. This 1's no longer important, but I'm going to leave it there for now. So 1 times x to the 1/4 is simply x to the 1/4 power. In the denominator, I get x to the 3/4 times x to the 1/4. So x stays the same, and 3/4 plus 1/4 is 1. So this is just x to the 1st power, or x. In the top, we're going to clean this up, and that means the denominator goes out front. And we're going to put the x to the 1st power inside, and we're going to divide that by x. And that's the best answer we're looking for. All right, if you have any questions, please let me know.